Hello, we will see multiprocessing in R. It means that multiprocesses execute the instruction. This is just like a suppose I want to do paint in my house, and if I hire a one labor, he will finish my work in 4 days. So what I am going to do now, I hire a four labor, and each labor has own work. So labor 1 paint wall of my house, labor 2 paint gate and windows of house, and labor 3 paint ceiling of house, and labor 4 paint back of the house. So if I hire a 4 labor, and then it will take only 1 day to finish my work, so my time is saved. So that is the kind of things you can imagine while doing the multiprocessing. So labor 1 here is a process. Okay, so here in this example there are 4 labors, so you can imagine 4 process. So likewise I want to do square root of each element of array, and this is the vector 1 2 3 4, and this is the independent task, so you can do parallel. So now what I am going to do, I create a 4 process, and each process do square root. I open the R Studio, and here is the vector 1 2 3 4. So I run this command, and after that I am going to activate the future library, and I am creating a multiprocess. So you have to type here, you have to use the plan function. So I open the window PowerShell. This is the new window, and this is better than CMD and build in the PowerShell you get in the Windows operating system. Anyways, so now what I'm going to do, I check the process to get process. This is the PowerShell command, and this is the all process running in my computer. So I have to check here R. So R script, as you can see, and this is another R script 1 2 3 4. So that means that it create a four processes. Why? Because I have a 4 core machine. If you have a 8 core machine, it will create a 8 processes. Now I so first let do normally how you perform this normally task. So I want to do square root of each element of vector. So I am using here sqrt function for that, and I write here v, and we get the square root of each element. So in the R everything is vectorized, so you don't have to write a loop here. So this is the normal code I wrote, and for parallel computing what you have to do, just only put the normal code, this is the sequence code, under the future function. That's it you have to do for doing the parallel computing in R by the use of future package. So this is very easy. You have to write here value to get the value. So I run this command. This is the same things. The only difference is it the first one is execute, the normal code is execute only by one process, and the future code I wrote, this code is executed by the four process. That is the only difference. Future package do multi processing asynchronous processing very easy. You don't need to worry about, you don't need to know about computer stuff, and this package automatically distribute your data also between the processes. You don't need to worry about how one process share the main process share the data between the sub process. You don't need to worry about it. But if you are using the future package, future automatically do for you. Now let's see some other code. These are some example of parallel task you generally find 80 to 90% in the computer programming. So First is different data and same function. So let us suppose that I have a data or data frame or list, whatever you can call. I have a x data, x vector 1 2, and the y vector. I want to perform, let us suppose, some function to the both the column x and y. So first I am creating a data here, and I am creating a map function. This is just like a apply function. The apply function you use in the R. I just write from the scratch. Now I am calling the function here, and you got 3 and 7. That means that it applies successfully. 1 plus 2 3, right? And 3 plus 4 7. You can do these same things by the use of apply function. I guess, I assume you know how to use the apply function. And this function, this code is executed by only one process. If I want to do parallel computing, parallel processing, I have to use the future package. So just put the code under the inside the future function. That's it. Now let's look the another example. Same data and different function. So I have a data like 1 2 3. This is the vector, and I want to perform sum function and mean function on it. So I run this command, and I also run this command, and I am writing another this function which do which do which apply different function to the same data. By the way, you will find this type of function, large number of function in the pure package, which is downloaded by the hardly become. And the here I am just writing my own sketch, own function from the scratch. Okay. Now this command, this is the code I want to perform in the multiprocesses. So I have to run this command. So as you can see that 6 and 2. So I have a data 1 2 3. I want to perform some function 1 plus 2 and 3 6. Okay, and I want to perform the mean function. So I will get the mean 2. The third example, let's see different data and different function. I have a data, and I want to perform function list. I want to perform this. I have a data, and this is the map function which do some work, and this is my function list. I want to perform sum and mean, and this is. So I have a data, I have a first vector here 1 and 2. I perform the sum function here. That's why it will print 3. In the another vector y 1 2 3, I want to perform another function like mean function. That's why it print 2. So this type of function you can also find in the pure package. Note here, the future package is only, you will see the effect of future package only if you have a large data set. Okay, if you have a small or medium size of data set, R is enough. R is well optimized for doing calculation. Okay, so in that scenario you cannot see the effect of the future package. We will see you will see the effect of the power of future package only if we calculate uh, the function in the large data set. I hope you understand how to use the future package and do multiprocessing. Thank you.